हेलो फ्रेंड्स, टेक्स्ट मास्टर में आज हम देखेंगे हाउ फंक्शन जनरेटर वर्क्स। सो फर्स्ट ऑफ ऑल research on a tab how first of all research what is function generator. So here some tabs or sub websites are open, so we open those website which is suitable for us and we learn from this website. So here are different website is open. So first of all we click on second website, function generator electronic links. So this site can't be reached, so we back from this and we click on third website. Function generator is basically a signal generator that produces different types of waveform at the output. It has the ability to produce waveforms such as sine wave, square wave, a triangular wave, sawtooth wave, and adjustable frequency range is provided by the function generator, which is the range of some hertz to several hundred kilohertz. There exist various function generators that have the ability to produce two different waveforms simultaneously by using two different output terminals. Function generator is a versatile instrument, has an extensive variety produced by it. The various waveforms generated by the function generator are suitable for various applications. It provides adjustment waveform, frequency, sine wave, magnitude and offset, but required a load connected before adjustment. This instrument not only varies the characteristic of waveform but also has the capability to add a DC offset to signaling. Mostly these are only able to operate a low frequency, but some costly model can also be operated at the higher frequency. As we discussed earlier that it can generate two different waveforms simultaneously at the two different terminals. So it can be a useful feature as different outputs are required for particular application. It provides another important feature as they have the capability of phase locking to an external source. This implied that a function generator can phase lock another function generator and the output of the board can be displayed in phase. Block diagram of function generator is frequency control network, external frequency control, constant current supply source, integrator. So constant current supply source to integrator, voltage comparator, multivibrator, resistance diode, shaping circuit, some output amplifier. So again we see both frequency control network, external frequency control, constant current supply source 1, constant current supply source 2, integrator, capacitor, voltage comparator, multivibrator, resistance diode shaping circuit, output 1, output 2. A frequency control network used here. Those frequencies controlled by the variation in the magnitude of current. The current sources 1 and 2 drive the integrator. By using function generator, we can have a wide variety of waveforms. Those frequency change from 0.01 Hz to 0.100 kHz. The two current sources are regulated by the frequency control voltage. So, a constant current is supplied in the integrator by current supply source. Due to this voltage of integrator rise linearly with respect to time. This linear rise is according to the output signal voltage equation. V out equals to minus 1 upon C FTO IDT. Any decrease or increase in the current will resultantly increase or decrease the slope of the voltage at the output and thus controls the frequency. The voltage comparator multivibrator present here cause vibration in the state of the integrator output voltage at a previously determined maximum level. Due to this change of state, the current supply from source 1 cuts off and switches the supply source 2. A reverse current is supplied to the integrator by current source 2. This reverse current causes drop in the output of integrator linearly with time. As before, this time also when the output attains the predetermined level, the comparator again changes its state and switches to current supply source 1. Thus we will have a triangular wave at the output of integrator. Those frequencies depend on current by the supply source. As we can see the block diagram show above, a square wave signal is obtained at the output of the comparator. The resistance diode network employed in the circuit and the slope of the triangular wave with distortion less than 1%. The output amplifier thus helps to provide two waves at the output simultaneously. This captured signal can be displayed by using an oscilloscope. Function generator provide a wide variety of applications such as RF related automation, automotive applications, in educational, medical, and industrial fields. ICL 08083 Intercell manufactured IC 8083 known as ICL address 8083 has a tremendous capability of generating various types of waveform. It uses three separate output terminals over a frequency range of 0.0, 0.0001 Hz to 1 MHz. The frequency of the circuit is controlled by an external voltage and may be determined by an externally connected resistor-capacitor combination. The 8083 is basically a relaxation oscillator that produces a triangular wave. Voltage comparator and digital tab storage device then internally convert triangular pulse into the rectangular waveform. When there is a need to convert a triangular wave into a sinusoidal wave, 16 internal transistors are needed to be employed. Thus, let's have a look at the pin diagram of ICL 833. Sine wave adjust 1, sine wave adjust, sine wave output triangular wave output, duty cycle, frequency adjustment, VCC, FM bias, NC not connected, not NC means not connected, sine wave adjustment, ground timing capacitor, square wave output, FM sweep input, sine wave adjust pin 1 and pin 12. Pin 1 and pin 12. These are these are used for connecting external resistor to minimize sinusoidal wave distortion. Duty cycle and frequency adjust pins 4 and 5. These are used to connect external resistor with that external capacitor known as the timing capacitor connected to the pin 10 to determine pin 4 and pin 5 to determine the timing capacitor connected to the pin 10 to determine the duty cycle and frequency of the outputs. FM sweep input pin 8. So here is the circuit diagram. This pin is connected with the external voltage adjusting the output frequency. These two pins denote no connection. So we can conclude that a function generator is an electronic component that generates various electrical waveforms. They cover operation of both audio and RF frequencies. This is a fixed frequency function generator. So here we learn about the basic concept of function generators. How function generators